So I'm back in the studio again. I've been traveling around doing a lot of stuff, reappraising a couple of projects, and my intention is just to smash through some things and make some stuff. And I'm going to be starting with this thing here. So this is not really sure what it is. Made in October 1962, Feu Autonome Type 189. I'll do the translation. This is all in French, and I think what it's come from is French railway, possibly. French or Belgian railway. And I think it's a lighting or an electricity thing. And I found it stuck in woods at the edge of the studio here with a tiny bit of bright yellow plastic sticking out, and I started digging and digging and digging and found more pieces, and I got a plan for this. We're going to take this and the various parts that do kind of there's a bunch of fitting together that kind of happens, and some more. I haven't been able to find all the parts of it, but I might go and do some more digging in the woods at the edge of the studio and see. But I like the incompleteness of it. I like this insane yellow color. It's this cuboid. I don't know what, and I'm not quite sure what I want to do with it, but what I want to do is, first thing is wash it, clean it up, and then with some epoxy resin and this that came in the post, which is glitter gold mica powder. We're going to mix these two together and do some Kintsugi, which is my modern version. This looks amazing. That looks utterly fantastic. Glitter gold, cosmetic grade, something, something, something. Kintsugi is the ancient Japanese art of repairing broken ceramics with gold, or with a resin impregnated with gold and then gold dust. And the idea is that the breakage and the damage and the repair and the imperfection makes things more beautiful. So it's a little kind of wabi-sabi, this art of beauty in imperfection. You know, cultural appropriation aside, I'm very sorry, I don't understand and I find it beautiful. Educate me in the comments. So we're gonna kintsugi this and repair it, and then I think what I want to do is take some of this stuff. So I have piles and piles of old electronics. So here is an Arduino di Similia, and I have a bunch of other Arduinos, and I want to do a piece of generative work with this, and it's been going round and round and round in my head, and I've been doing drawings of kind of what I want to do, and I want to do a one-dimensional generative piece, and I'm not sure whether it's color or just white. So I have some ultra bright LEDs that I bought like a million years ago for another project. Never got used. So hopefully they're good. Now I will work out how to wire them up. Oh, I have another Arduino in here with a big ultra bright, I think that's an RGB LED already as part of some circuit or other. So I think what I want to do is clean this, Kintsugi it, and then I want to get an Arduino running in it. I'd love to get it on solar power, but we'll add that later. We'll run it off batteries and a mains adapter for now. And I was drawing last night and thinking, what is it that I want to do? And I just want to have this thing sat here because I really like the physical presence. And it has this hole in the bottom. And I like the idea of it just glowing or breathing or something. And casting a circle of light out underneath, kind of like so. And I want to work through a kind of moving weighted average drunkard's walk type thing, so I get a streaky, lumpy randomness. And I don't want to use purlin noise for a variety of reasons that is a discussion over a beer another time. But I'm going to start with Kintsugi this, start fitting up the components, check if it's going to fit, and then start writing some code for the Arduino to see if I can get this motion and movement as though like a one-dimensional, actually theoretically it's two-dimensional if you believe that we live in a four-dimensional universe of X, Y, Z and time, but it's only moving in one dimension, which is going to be the brightness over time, as opposed to doing stuff on a screen, which is X, Y and time, or X, Y, Z and time. So we're going to do that with a bunch of resin, and we're going to glue a bunch of things, and maybe I'll just stick it on time lapse and you can see what happens, and then we'll get to writing code and shit like that later on. Okay, see you in a minute. So we're going to do some Kintsugi. I've got my glitter gold, and I've got my 2-part epoxy resin, skewers for barbecue kebabs, and I've cleaned up this amazing 1960s yellow plastic, probably made of, I don't know, weird, never dying industrial awful materials, but we've got it, so let's do something with it. First thing that I'm going to do is mix the 2-pack epoxy, and then I'm going to add in some of this, and then I'm going to use the barbecue skewers gently to smear the gold mixture on, and then when it's done we take a fine brush and brush more gold powder on the top so it has a surface of gold, and then any excess gold will brush off when it's done hopefully, and then we'll media art, put some blinky lights inside it. And I'm going to add an extra bit of light. This is one of my Ryobi lights, which are just absolutely fantastic, and I got a bunch of them that work really, really well. I've dropped this so many times and finally gave up. I took it apart and fixed a bunch of it. So Ryobi, please send me some lights. They're really, really cool. Add some gold into that. Okay. So we have our epoxy, the hardener's in there, it's going to start going off, and I'm going to try and not make a real mess of this, and the trick is to get it in. Window. And not, yeah, there we go. Cosmetic mica powder, glitter gold. Glitter. All we need now is blinky lights and one-dimensional randomness, which may be a drone warp. We shall see about what kind of shape to make out of luminous box. It's not a thing, it's covered in glitter. That's great. That's much more what I wanted. You can see as a beautiful splurge of gold on the inside and the outside. And I'm going to give it a minute, dust it with more gold. and then we leave it to harden. And we start to work on the next stuff. Mooching around through all of the stuff in the plastic recycling trash, I actually found this 1990s Vata clip-on torch that has this odd swivel head, and I disassembled it. And it has a nice little lens in the end. It's kind of corroded, but working through, got the bulb out and got it powered up off this Arduino I'm playing with here. And maybe I'll swap it out for an LED, but for now that kind of does what I want. So I'm cleaning up the contacts, and hopefully I can get this all together. And take this with the lens, take my now fixed, beautiful looking weird plastic thing, and this fits there, I think. And then I can take the body inside and do stuff. So I think I'm going to use this, maybe keep the bulb holder, maybe need to rewire. Oh, this dust, gold glitter everywhere. So maybe I need to rewire some of this, check the contacts, and I'll get a multimeter on it and see where we get to. So the swivel head from the broken 1990s torch that I want to use is all good, but one of the swivel connections inside is busted, and I think rather than trying to repair something that's not ever designed to be repaired, I'm gonna drill through the back. I'll run some new cables through, and that can go to the original bulb, and that'll go in, and that'll seat under there. I've got some nice LEDs that will go in and adapt to the original bulb holder, and that gives me that part, and then I can run the cabling in. I've been doing stuff with Arduino. It's been a bit funky because I've got some quite old Arduinos, and I'm running on a new Mac M2, which doesn't have an old USB. It has USB-C, so I need to check what's going on with the hardware and the serial ports, because it's not addressing the Arduino correctly. But we'll do the hardware stuff, and then we start working with the software, because when I've got this mounted, I can just put it in place and see, does it look right? Does it feel right? So I'm going to get out Dremel and drill some holes in some stuff and recable it. Job done. The epoxy resin is cured relatively hard. It'll get stronger over the next 24 hours. Mostly I got it in the right place, and now I can brush off the excess gold powder, and you can see what's going on. So I'm gonna take the base of the torch as well, slots in. There's a nifty little clip that goes in there, so I'm going to cut the base out of this. So while the Dremel's charging, I've had a junior hacksaw, which honestly, it's making a cleaner job of it. Maybe. That's sort of what we want. That puppy clips on there, little clip goes in, that gives us a mount under our yellow box. I can drill straight through the center of here when the Dremel is charged. Tidy it up, grind it, resin it in place. Everything's good. So I'm going to fit my straight on, shrink, rat. Oh, it's in. And let's open it back. And that's cute. And it's a bubble, and the rest that's good. And it's really done. It's good. I'm just going to need to. She's almost. It's not on that racking, that line. Realize yesterday. Realize the structure. Actually, I'll just get that through there. Just stick it in. Okay. That's really good. Then. Ready to put it in. All good. Next stage, getting the coding going on the Arduino and then fitting it all together and deciding whether I want to explore solar power for it, because I don't really know very much about solar power, but I'd like to. Back in studio, and I've got a test board with Arduino Milanova, old 2009 little breadboard, and super simple circuit. I've got a big LED with a 300 ohm resistor wired up, and I'm just sending power on pin 9, and been digging around trying to find a power supply, and in the junk, I've no idea what this was from, but found a wall wart, puts out 9.5 volts, 400 milliamps, it'll do. And of course, I've got a USB cable that I can power it off the Mac laptop I'm working from, but when I finish sending code to it, I can run it off this, and I've also been mucking around exploring what stuff I've got here. There's some weird little old solar cells, and I've got some big solar cells, and trying to read up about that. But for now, we'll just power it off the wall wart when the code is done and get it all packaged in here and see what it looks like. So we've got the swivel bulb and all of that stuff, flying leads. Now I want to think about what can I do, because I'm kind of doing this one-dimensional generative in that all I'm going to control is the brightness of the light. So I have, just the voltage and time. So it's kind of two-dimensional, but it's actually one-dimensional if you take time out of it. And I have an idea of the pace and the rhythm that I want. So I'm going to start writing some simple code, but I want to have a think about what the parameters are and do a little bit of drawing. So what I can do is just think about, this is time, this is brightness, and start off 0 brightness, and I can ramp up to a brightness value over a period of time. And then potentially I can hold that brightness value for a period of time, and then ramp down to another brightness value. So I can just control this with a counter, and then using a random function to set my brightness value. So thinking a little bit about what does this feel like? It's breathing, but I don't want it to be breathing. I don't want it to be regular breathing, but it has a sigh, and I think I want something like that. I did some original drawings of what I might want to do, and this is very, I don't know whether it's gestural, but there's periods of stability, and I want some stochastic, this kind of spiky texture alongside some smoother elements, which it's all change. It's just changing modifying the time aspect. So I want to code that up, and I'm going to go to the Arduino editor and start making a simple loop that will just give me on and off, and then start to add my variables in, which is being able to set a change from one brightness level to another over a period of time. So we pick a target with a random brightness, and we pick a target for a random amount of time, and it ramps from one to the other. I'm just going to go for straight values. We could change all kinds of curves, maybe using easing functions, and then a period of time to hold that brightness, and then a new period of time to go to a new brightness level, up and down. So we see how that goes. I have opened up the Arduino IDE. I had to download the latest one to work with this Mac, which is a Mac M2. And I'm actually modifying one of the examples, which is really great. And what we get is, I'm going to start up and say a couple of things. On my circuit, I have the LED connected to pin 9. And I'm going to set up some variables to say the LED state, so it'll tell me whether it's on or off, because what I want to do is decide to ramp up or ramp down the brightness. And then I'm setting a variable called previous milliseconds, and then I'm going to set a basic interval at 3000 or 3 seconds, a random gap of how long we're going to wait of 6 seconds, 6,000 milliseconds, and a maximum delay, which I'm going to use for the delay when we're looping, changing the brightness value, because I need to set the brightness and then set the brightness higher and set the brightness higher and set the brightness higher. So it's how fast that'll change the maximum, which is going to be half a second of each step of increasing or decreasing the brightness. And then I'm going to add some new variables, which I'm going to keep using to say what is the random gap between changes in brightness and the maximum brightness that we can get to. So there's nothing happening in the setup, but in my loop, I've got a couple of things going on. So here is my whole loop. And the first thing that I'm going to do is say that the current milliseconds variable is now. So I call, get me the current milliseconds, and it gets it from the system time. So every time the loop goes, it says, what time is it? What time is it? What time is it? And if our current time is equivalent to the interval and the random gap since the previous time I checked and it was correct, I say, let's do this. So we go into this if statement, if now current milliseconds is equivalent or later than the last time I checked, plus our random gap. And then I just reset it to say, okay, we've run this, and this is our new checkpoint. So when we think about our map here, I'm saying at this point, choose an amount of time to wait and keep checking is now equivalent to when I started the loop plus this amount to wait. And when I get there, reset it. So now is here, and I choose a new amount to wait, and I keep checking and checking and checking until the time is equivalent to that plus our amount to wait. So this is how we do a timing loop. And if the LED state is low, i.e. it's switched off, I'm going to say now set it to be high, and then I go into another loop just here where I fade from 0 to whatever the maximum brightness is, and I loop through with fade value being +2 each time. So I'm start at 0, up in 2s to whatever maximum brightness is. And then I use the analog write to the LED pin, which I set earlier, pin 9, with whatever the fade value is. So it fires this brightness value to the LED and then causes a delay of our delay time, which we set as a variable earlier. Now, if we've got to this point where we're executing the loop and the LED state's not low, then it must be high. So we do this other in the else. And if the LED state is high, then we now need to set it to low, like a toggle. So it's just going high or low, depending upon whether we fade it up or fade it down. And then we do again this fade loop. But instead of going from fade value as 0 to max brightness +2 each time, we're going from fade value as max brightness to fade value as 0, taking away 2 each time. And then we use the analog write to fire it at the LED pin, whatever the value is, delay again. And then when we've ramped up or ramped down, we make a new random gap variable. Remember, we're using this to count how long until the next event, which will be a fade up or a fade down. And what is the delay time, which we're using to say how fast is this fade up or fade down. So we make two new random variables for the gap until the next event and the speed that we're going to ramp up and ramp down. So if I send that out to my Arduino, it's uploaded into the board, and we should see this right here. I'm going to turn off some of these lights and we might be able to see a little bit more of what's happening. So we've got up to 6 second wait, and then half a second of steps in the ramp time, and up to 125 of those. So we could have a ramp speed of 12 seconds or so of going from one brightness to the other. So this is pretty slow. Now it's fading to a new brightness, and now it's almost off, and now it's fading to another brightness. And I've been playing with some of these values. Initially I was running this much faster, and I was sat watching and watching and watching, sitting with it for hours and hours and hours, and playing different values and finding this pace that I kind of like, of this thing fading up, fading down, and picking new brightness levels. And sometimes the fade is very, very slow, and it doesn't go to a very high brightness, so it has this incremental kind of tick, and you're half not sure, is it going somewhere? And then it slowly goes away, and then occasionally you actually get quite fast changes. I might want to add some more texture so that every X amount of time, quite a long period of time, we get short, fast changes. But we'll see. I want to get it all installed and then see how it looks in here. And I think sit with it at night for a little bit and see what happens. So my code is pretty simple. And it's doing a couple of simple things, but it's giving us all of this. One-dimensional randomness with two stages interlinked, so it's like a higher-level stochastic function, probably. So we've got the code on our Arduino. And it does what we want. So I'm going to replicate the simple circuit, get it running through the filament bulb, and cable it all up, and then just sit with it for a bit and see what it feels like. So I guess we do that. Great. I guess if I'd thought about it, I could have wired my resistor in on the positive line, but I will maybe kludge that and put it in here. Oh, yeah.